All right, folks, it's Bass Action, back in action here. In this video, we're going to show all of the basic transformations. Know that we are going to graph each of these, so you might need to pause this video along the way so that you can make sure that all of your graphs are actually correct as well. All right, let's jump into our first one here, and the transformation that we can see here has this +2. Now, what I want to call your attention to is that this +2 is outside of the function. We can look ahead just momentarily over here at B and notice that the +2 on that one is inside the function. It's actually attached to that x. This is going to be a different transformation than our first one. Our first one, because that +2 is outside of the function, is going to be a vertical shift. That means that we're going to move the graph either up or down. Now, vertical shifts are pretty easy to do because you don't have to do much thinking on it. You can just read it straight from the graph. So in this case, that +2 says that we are going to move all the y values up 2. That means that as I come over here to each of my points, I'm going to move them. So if I'm at this -6, 0, I'm going to move that point up 2. I don't have to do anything else to it other than move it up 2. I'm going to move each of these points, moving just from left to right, up 2. And if I go off my graph, which I think this one I will, because I wasn't able to get a proper size grid on here, and I'm going to get all my points up 2, then I can connect them, and it should just look like your graph has just moved up 2, the whole thing. Now, one thing I kind of like to do on my notes is I like to go back and I like to color those points in a different color, kind of make those stand out a little bit better so you can see a little more clearly when you go back later what the shift has been. Now, let's go over here to the right, this one that I called your attention to earlier. Because this +2 is attached to the x, this is going to be a horizontal shift. Now, anytime you have a transformation on the x's, it's going to be a little bit more work for us. So on a horizontal shift, what we're going to do is we're going to grab this entire expression that is on the x, and we're going to mentally, or in this case, we're going to actually write it down, we're going to set it equal to 0. Okay, we're thinking what value is going to make this expression equal 0, and if we solve that, we get a -2. That means that we are going to shift everything to the left 2 or move them -2. And it's important that you think that out each time. It's not always a just do the opposite, which is what students often want to do. In this case, we have taken this, we set it equal to 0, we solve, and that tells us what our shift should be. Now, that means that we're going to take all these same points, and instead of going up 2 like we did before, now we're going to go back 2. So I'm going to move the -6 back 2. I'm going to move the next one back 2, then back 2. And some people even like to connect as they go along, and that's also fine. So we're going to move these back 2, and back 2, and back 2, and back 2. And just like before, I said it's sometimes kind of nice to go back through and color those points that you moved. It'll make them stand out a little bit better as you're going through your notes later. All right, now let's look at our next transformations. Now, on our next transformations, these are going to be our reflections, and you need to be able to recognize what kind of a reflection this is. So if our reflection is out here on the outside, it's in front of it, this reflection is going to be a reflection, so we're just going to write reflect over the x-axis. Now, sometimes students have a hard time remembering that, so what I always picture when I was a student is I pictured that negative being out here on like a -x². Most students are pretty comfortable remembering that that would make the parabola go from turning up to turning down, and that's essentially what we're going to do here. So on this one, we're going to change all the y values. We're going to change all the y's to negative y's. Okay, so if they were negative, they'll become positive. So we're going to do that again. Now, of course, this very first point is still sitting right here on the x-axis. That y-coordinate of 0 isn't going to change, but my next one that's down here, my next one is going to flip to a positive. So instead of a -2, it's going to become a +2, and then I'm going to be back here. Now, when you're doing reflections, it is sometimes nice to connect as you go along. That is one place where it is handy. So my 6 as my next point is going to become a -6. I'm going to move that down. Then I've got another one that's a -6. I'm going to connect as I go. The next one's going to go off my grid next time, because again, my grid's not quite the right size, and that's okay. And my next point is going to come down here, so we can connect those. And just like before, we can go back through and we can color these dots, each of these points, and our graph should look like it's a nice reflection over the x-axis. Now, if this was a reflection over the x-axis, then when we go right next door, this one should be a reflection over the y-axis. So that logically would make sense here. So we're going to reflect over the y. And if we're going to reflect over the y-axis, now we're going to change all the x coordinates to negative x's. And again, just like before, if it was a negative, then it will become a positive. Now, sometimes I think this one can be a little bit confusing to do. So again, I would suggest kind of connecting these dots as you go. So our -6 is going to become a +6. And then our -4 is going to become a +4. Notice I'm keeping the y values the same. The -2 is going to become a +2, and I'm going to start drawing this. Now, instead of left to right, it's going to start to go right to left. Now, my next one is right on that y-axis, so it's not going to move at all. And then I'm going to have my +3 is going to become a -3. Notice I'm connecting as I go along. Then my +7 is going to become a -7. Sorry there, -7. And then my +9 is going to become a -9, and I'm going to go off my grid just a little bit. It's not the end of the world here. And then I'm going to go back through and I'm going to color each of my points with a different color to kind of make those pop out a little bit better. But now we can see each of the pieces is a nice reflection over the y-axis. The last one we're going to do are going to be our dilations, okay? And as I said at the very top of this, when things are done on the y's, it's going to be our easiest. So on our first one here, we can see this 1/2 is outside of our function versus on G, the 2 is on the inside. This is going to be our easy one. This is going to be our vertical dilation or a vertical stretch or a compression, lots of ways to say it. Okay, so this is our vertical dilation. And to do this, we're going to multiply all the y's by whatever value is in front there. So in this case, by 1/2. So now we're going to just repeat our process. Our 0 times 1/2 is 0, but our -2 for our y value is now going to become a -1. And then our 0, I'm going to connect as I go. My 6 is going to become a -3. I'm going to go straight across. Still at a -3. My 9 is going to become a 4.5. Just kind of spitball where that is, and then I'm going to be back there. And then I'm going to go back through again, and I'm going to color each of those points. So it kind of stands out, and you can see that the graph has been compressed by 1/2. Now, our most challenging one is our last one here, so we can put a big star on this one. Our most challenging one is when we have a horizontal dilation. This is going to be the most challenging one, and what I always tell students to do is to think about this horizontal dilation, think of it as like a speed, okay? We're thinking about somebody driving fast. So if somebody is traveling twice as fast, they're going to get to where they're going in half the amount of time, okay? So if we're going twice as fast, we're going to finish in half the time. That's why we're going to take all of our x values and we are going to either think divide by 2, Or you could think multiply by a half, but really we're multiplying by a reciprocal. So this time we're going to divide them by whatever coefficient is there. So all my x values are going to get divided by 2 this time. So my -6 is going to become a -3. My -4 is going to become a -2. My -2 is going to become a -1. And that little bit has just been scrunched down. 0 is going to stay right here at 0. Then my 3 is going to become a 1.5. Now it's really, really short. Okay, my 6 is going to become a 3. And come all the way up here to my 3. And my 9 is going to become a 4.5. And I'm going to color those dots one more time so you can see those a little more clearly where they are. All right, on the next page, we're going to combine dilations and shifts, and that definitely adds to some complexity for us.